Now let's take a look at procedural geometry creation. So for this example, let's create a simple procedural staircase. So let's create a geometry node and dive inside. And here let's add a helix. Let's bring up its parameter. So here we have a helix. Let's adjust its height and let's make its radius to a lower value, and let's add a sweep swap. And now the sweep swap is throwing an error, so because we don't have the second input cross section, so let's change this from surface shape second input to ribbon. So here, as you can see, the orientation is not correct, so let's go back onto the helix and onto the output attribute, and let's turn on the orient attribute. So now the orientation is correct. So let's go back onto the sweep swap and let's adjust its column to 1. And for creating these step, let's add a group node, group by range. Connect that. And here onto the group range, we can set the different range for the geometry selection. So let's change the parameter here onto the range filter. Let's select every one of 2. So now we are basically skipping every face, and let's name our group to steps. Let's add a poly extrude node, and for the first let's add a thickness by increasing the distance. And as you can see, we don't have the bottom piece, so let's add output back to create a more filled geometry. And now let's add poly extrude again, and here onto the group, let's set our step group that we have created, and let's add its distance. So here, as you can see, we are creating the steps, but when we created the thickness here onto the poly extrude node, we have the group selection on both sides. So let's remove the bottom part from it. So for that, let's create another group node and connect that. And here let's uncheck the base group and go into the keep by normal, and onto the normal direction, let's compare this by y-axis and zero out the z, and let's decrease the spread angle just until we can select the top side of our staircase. Okay, so let's name this group to top. So here onto the where we have created the step group, so let's disconnect it from here and connect it here instead. And here onto the group range, let's select our base group to be top. So now we are only working on the top side of our geometry, and we are selecting every other polygon face. So now let's create a poly extrude. So now we have the extrusion applied correctly. Okay, so here I can go back onto the helix and I can adjust the radius, I can adjust the height as well as the number of turns. And now let's add the railing onto our staircase. So after the poly extrude, let's add a blast node to isolate these faces of our steps. So let's add a blast node, and here onto the group, let's select the group steps and choose the delete non-selected to create an inverted operation. Okay, so here we have these top faces of the staircase. So let me bring it here onto the side. And for creating the railing, let's use the loops to loop at every steps one at a time. So we can loop at every piece by using the for each. So if you type the for, here we have the loops, so we can loop for each number, each point, each primitive, or we can use the for each connected pieces. So let's add that. So what it will do, it will add a connectivity sub to assign an attribute to all of these connected pieces and run onto each of the connected pieces separately. So if we set the display flag onto the for each end, and let's bring up its parameter of the for each end, and let's check the single pass. So here, as you can see, now we are working only on one of our step. We can change the single pass step here. Okay, and if we uncheck, now the loop is going through every single of these pieces and merging the result back. So let's check the single pass and use our first piece, and here let's add a subdivide to add more division onto our step, and let's select our center edge. So let's go into the selection tool and change the mode from primitive to edges. Let's select these center edges and type bevel. So let's increase the distance. So we can always come back and adjust its distance, okay, by using this parameter. And now let's isolate these points for placing the staircase railing rods. So if I enable my point display, so we are interested in the point 8 and the point 11. So let's add a blast node and change the group type to points, and let's select the 8 space 11 and click on delete non-selected to isolate these 2 points. Okay, so here we have these 2 points, and if we uncheck the single pass, so here as you can see we have created this operation onto each of our pieces. Okay, and let's now add a line, and let's disable the point display. Let's add a line and use the copy to point sub to copy the lines onto these points. Okay, so here we have these railing rods. Let's adjust the length to a lower value, and let's add a sweep and change this to round tube, and let's lower the scale. And let's also add these end caps by going to the end caps, change this to single polygon. So now we are adding the end caps. So let's merge this with our staircase steps. So let's add a merge node. So these are the railing rods. Let's set the display flag. So now we are creating the railing rods. So now let's connect these rods. Okay, so for that let's group our very top point. So the point number is 1. So let's add a group node and change the group type to points, and let's name this top, and we want to group our point number 1. Okay, so when we copy, all of our group will be copied as well. So let's add a blast node to isolate our top group. So here onto the blast, let's choose our top group. So here we have the top groups points. So now let's connect these points to create one single spiral curve. So let's add an add sop, connect that, and let's go into the polygon and let's change this to by group, and we are now connecting the all points. So now the connection is not correct, so they are connecting in a zigzag style, so we don't want that. So for that we can use the attribute, so we can connect these points by using the attribute. So let's select that. So here we can define the attribute, so let's create an attribute for that. So we can create an attribute at this stage where we have isolated these two groups. So if we create an attribute on there, so when we copy, our template point group will be copied onto these lines as well. Okay, so let's add an attribute create node. Let's create our attribute ID, and let's change the group type to point, and for the first point 0. So here onto the group, let's choose the point number 0, and for the 0 the attribute value is 0. Now let's duplicate this node one more time. Let's connect that, and for the point 1 we want to set the ID value to 1. So now when we copy our geometry onto these points, we will have the attribute name ID. Okay, so after the blast, we'll go into the ID, go into the add, and use our ID attribute. Okay, so now we are connecting all of these points correctly. Okay, so let's delete this sweep node, we don't need that, and let's merge both of these curves and these railing curves, merge them, and let me uncheck the display point, set the display flag to merge. So here as you can see, we are creating the railing line onto the wrong side, so we want at the upper side. So let's see where we have the problem. So here onto the top, so the top group is fine, and after the copy to point sop, and now it appears to be in inverted, and that is because onto the blast node we are deleting the top node, so we need to check the delete none selected to isolate our top points. Okay, so that was the problem. So let me untemplate my copy to points. Now if we add and see with the merge, so now as you can see we are adding these railing line correctly. So after that let's add a polybar. Let's connect it here onto the polybar parameter. Let's lower the radius down to a small value, and let me uncheck my UV visualization. Let's increase the division for more smoother cylinders, and here as you can see these pieces are not connected, so here we can add a fuse to connect these unconnected points. Okay, so now we are connecting our geometry. Okay, so now let's merge this. Press and hold the Y key on your keyboard to cut the wire, and let's connect this into our stream. Okay, so here we have these railings, and now let's add one big cylinder at the center. So let's create an align. So here we have the align, and here we have the helix. So let's add a match size to create a same size line. So this is the line that I want to resize, and let's use the bounds of the helix. Okay, let's go into the match size and check scale to fit. So now we are using the helix bound to set the scaling of our line. So which means if we change the height, our line height will be adjusted accordingly. So let's add a sweep node to create thickness into our line. Change this to round tube, and let's give him some more columns for more smoother cylindrical shape, and let's add its end caps, single polygon. And here onto the line we can adjust the points to add height segments, and let's merge this with our end results. Okay, so now here we have the center pillar, and here onto its radius, let's link this radius with the helix radius. So where it says start radius, so let's copy this parameter. We can say copy parameter, and onto the sweep, onto the radius, select the paste relative reference. So now we are basically referencing our scale. Okay, so whatever the scale we will define here, now this parameter will control this parameter. Okay, so here as you can see, by using the same radius, so we are basically intersecting with our staircase. So let's go on to the spiral node, and down here onto the transform, and here onto the uniform scale. Let's add a uniform scale on top of the start radius. So let's increase its scale until we are happy with the contact scale. Okay, so that is looking good. Okay, so now when we adjust our radius, it will work perfectly. Okay, so here we have the procedural staircase. So we can adjust the number of turns, and we can increase the number of steps by changing the division per turn. Okay, so here as you can see, we have some problems at the end. Okay, to avoid this, let's change the division mode from division per turn to division per curve to create a more consistent. Okay, so now we still have some problems. Here as you can see, when we are using the even number, we have some problems. So if we use the odd number, it working fine. So to fix this, let's go on to the group by range. We can offset this parameter so that when we have the odd number, we can add a 1 at the offset. Okay, so let's go on to the helix, and let me untemplate my group range, and let's copy our division per curve parameter. So right click and say copy parameter, and go on to the group range and onto the offset. Let's choose based relative reference. So now we are basically using the same value as we have onto the division per curve. So to calculate the even or odd, so let's click on the offset and click on the parameter and press the Alt E on your keyboard to make this window bigger. Okay, so after we have evaluated the channel reference, we can say mod. So the percentages sign here mean mod, so we can say mod 2, hit apply and accept. Okay, so what it will do, so the modulus will give us the remainder of the after the division. So when we have the odd number, we will have the remainder of 1. So when we have the even number, so let's change this to 140, we will have a remainder of 0. Okay, so let's see if that fixes our problem. So let's set the display flag onto the merge, and it seems that we need the other way around. So what we can do, we can add 1. So first let's add 1 plus this calculation. Okay, so now it should work fine. So if I change the parameter, now we don't have the problems at the end. Okay, so now in the next lesson, let's see how we can create this procedural staircase geometry and turn this into an Houdini digital asset. Okay.